Okay, so all balloons and laughing aside, what did we decide was in your balloons?
Gas.
What kind of gas?
Hydrogen.
Maybe some hydrogen. What else? What?
Water vapor.
Some water vapor. What else? Some O2. What else?
Nitrogen.
Some nitrogen. What else?
Maybe CO2.
CO2. Yeah, because it should be primarily CO2 because you actually exhale CO2, but there will be some other atmospheric gases mixed in. So it's going to be mostly CO2, but there will be some little trace amounts of all these other gases. Here's the thing, Dalton, remember him? What did he do? What theory? Dalton's atomic theory. Yeah. So English school teacher, 1890s, thinking a lot about atoms, thinking about gases also, and thinking about pressure of gases. And here's what Dalton said and later proved. If you have a mixture of gases and that whole mixture is under some given amount of pressure, the sum of their individual pressures equals the total pressure. So if the entire collection of gases in your balloon is sitting at atmospheric pressure, which, today atmospheric pressure is probably, we could read it, but let's just assume it's, 755 torr. Okay? Then the pressure inside that balloon is the sum of the individual pressures. Okay? So we could take out the pressure of the water vapor and the pressure of the nitrogen and the pressure of the hydrogen gas and the pressure of the oxygen, and we can figure out what each of those individual pressures is. The pressure of the CO2. We can figure out those individual pressures. Why does that matter? Why do we care? We care because very often we collect gases from experiments. We do what's called a water collection. I'm going to show you the apparatus. We've got a very bad drawing of a gas collection setup. But basically, when bubbles travel through this tube, they're going to travel up into the cylinder. They're going to displace water. And so what we should end up with up here is whatever gas we produced in the reaction, right? Great. There's just one problem with that. Do you remember what I've said about water once or twice? Water is only attracted to two things in the entire universe: itself and everything else. So when those gas bubbles, let's say this is hydrogen gas we're producing, when those hydrogen gas bubbles come up through the water's like, no, I don't want to miss the party. And you'll have a few little bits of water vapor that get dragged up into the top of that chamber. So then what you have here, instead of just being hydrogen, is you have a mixture of H2O gas and hydrogen gas. And what you have to do is figure out how much of the pressure that you're observing in that cylinder, because you want to figure out the volume, and to figure out the volume you have to adjust for the pressure. So you have to figure out how much of the pressure of that gas is actually water vapor. And it's a real simple lookup. We're not going to do them. There's a chart in the back of your book, but for any given water temperature, we know experimentally how much water vapor is going to be mixed with your gas. So let's look at that real quick. So what this does is we look at the temperature of the water that we're pulling through, and we know that at 20 degrees Celsius, we're going to have 17.5 torr of water vapor pressure. So we subtract that out from the total atmospheric pressure, and then we have the pressure of just the gas that we're interested in. Okay. We also have it in kilopascals, but I hate kilopascals, so we're not even going to use that. Just my thing. I just don't like them. That's it for partial pressure and water vapor pressure. So I mean, this is why we use combined pressures, because water vapor pressure has to be subtracted out. And what you'll see, if you're going on in chemistry and you do any problems that involve water vapor pressure, what you'll see is something like, what is the pressure of the dry gas? Dry means you've subtracted out the water vapor pressure. So. And that's it. So we will have a FIP quiz on Monday on the combined gas law. So And I'll tell you what, I'll do one partial pressure problem. So I'll assign that quickly. Okay, number 39, number 41 in the book, 5th quiz Monday on combined gas law and partial pressures. That's it.